Welcome to our factory. Today, I'll show you exactly how smartphones are manufactured step by step. Don't forget to subscribe for more behind-the-scenes videos like this.
Silicon is the backbone of every smartphone, not because it's rare, but because its atomic structure allows
Smartphone glass isn't ordinary glass. It's chemically strengthened, its surface compressed at the atomic level. Energy density is the defining challenge of mobile technology. Lithium is used because it stores a high amount of energy relative to its weight.
Some of the smallest components rely on rare earth elements. These materials enable powerful speakers, precise vibration motors, and compact sensors.
At this stage, purity matters more than volume. Microscopic contaminants, imperceptible to the human eye, can cause failures later.
Only once these materials meet exact standards can manufacturing begin. Because in smartphone production, performance isn't...
Raw materials can't be used as they are. Before a single component is made, these materials must be reshaped, purified, and stabilized.
Aluminum starts as molten metal, cast into uniform slabs. The goal here isn't...
Computer-controlled milling machines remove material with extreme precision, often within microns.
The Czochralski process allows us to create the ultra-pure silicon required for modern semiconductors.
Glass panels are cut and chemically strengthened at this stage, not later. By locking durability into the material early,
Copper layers form the highways for electrical signals. These base layers must be uniform and
before these parts ever reach an assembly line, they're inspected repeatedly. This stage exists for one reason. Catching defects early is... This is where smartphones truly come to life.
Despite the automation, this process still depends on people. Engineers monitor temperatures, pressures, and...
Transistors aren't carved, they're printed using light. Photolithography projects circuit patterns onto silicon with wave...
Etching removes material at the atomic level. Doping adds trace elements to control how electricity flows.
One microscopic defect can ruin an entire chip. That's why engineers obsess over yield, the percentage of usage.
Some steps take hours, others take days. Engineers don't rush them, because at this scale, when this process succeeds, the result is extraordinary. Billions of transistors working in harmony.
These chips will travel thousands of miles before reaching a phone.
If the processor is the brain, the circuit board is the nervous system. This is where power, data, and signal.
These machines place tens of thousands of components per hour. Each resistor, capacitor, and chip must land perfectly.
Humans can't see these errors directly. Instead, they read data, optical measurements, alignment tolerance.
Solder doesn't just glue components in place, it forms electrical bonds. Inside these ovens, temperatures are tuned to bring.
Every board is inspected by machines trained to spot flaws humans might miss. But the final call...
When boards fail inspection, they're not always discarded. Skilled technicians can rework microscopic connections, saving components. Before a circuit board ever enters a phone, it's electrically tested. Power delivery, signal integrity, and...
At this point, the phone's internal network is complete. What remains is integration, bringing power, sensors, display. This is the only part of the smartphone the user ever truly touches. The display isn't just a component, it's the interface.
Everything begins with glass. It must be perfectly flat, optically pure, and free of stress.
For OLED displays, each pixel emits its own light. That means multiple organic layers must be deposited with nanometer precision.
No two displays are naturally identical. Human technicians fine-tune color balance, brightness. A display must not only show information, it must feel responsive. Touch layers convert pressure and movement into...
Displays are stressed,
before users ever touch them. Flexing, heat cycling, and pressure tests.
This is the moment engineers wait for. When a display lights up evenly, no dead pixels, no color shift,
Only after passing every optical and mechanical test are displays cleared for assembly.
As smartphones become thinner and more powerful, their most critical components must shrink, without losing reliability.
A smartphone camera isn't a single lens, it's a stacked optical system. Each element must align perfectly. Machines assemble the optics, but people calibrate perception. Engineers fine-tune focus, color accuracy.
Energy density is the defining challenge of mobile technology. Lithium is used because it stores a high amount of energy.
Every battery is stressed beyond normal use. Heat, vibration, and load tests reveal weaknesses early.
Look this. Sensors allow smartphones to respond touch, movement, and identity.
Before integration, every module is verified by human hands and human judgment.
These parts don't just add features. They define how the phone sees, feels, and endures.
This is the moment every previous step has been preparing for. Final assembly is where...
The frame isn't just structural, it's a reference point. Every component must align perfectly, or stresses build up that can... Some steps can't be automated. Humans handle tasks that require judgment, feeling resistance, sensing alignment.
Sealing the device locks everything in place. Adhesives cure, screws are torqued precisely, and water-resistant barriers are formed.
The display is installed last because it's fragile, expensive, and unforgiving. Alignment here affects everything the user will see and touch.
This is the first time these devices come alive. In seconds.
Before testing, humans make the final call. They check what machines can't measure, how the phone feels, how it looks, how complete it seems.
At this point, the smartphone is whole. What remains is validation, proving that it can survive the real world.
These phones are only machines. Software is what gives them identity. How they think, communicate, and
displays are tuned, sensors aligned, cameras balanced. These steps ensure that consistency takes their place.
Engineers verify antennas, radios, and signal stability, ensuring the phone performs reliably across networks.
Engineers look for crashes, overheating, or slowdowns, because problems discovered here never reach the user. Humans check what data can't: responsiveness, smoothness, sound quality. This is where engineering meets experience.
Some phones return for rework. Others are dismantled. Quality control exists to protect the integrity of the product.
Only after surviving every test is a smartphone approved for release. At this point, it's no longer just assembled, it's trusted. After passing every test, smartphones enter their final phase, preparation for a journey far beyond the factory. Automation moves fast, but people ensure every device is packaged correctly, protected, and presentation ready. This is the last moment imperfections can be caught, before the product leaves human hands. Each box is routed with precision, tracked, timed, and directed across a global logistics network. Warehouses synchronize supply with demand, moving millions of devices with near-perfect timing. From here, smartphones travel by road, sea, and air, often crossing continents in days.
Every shipment is signed off by people, because accountability never disappears from the process.
What began as raw materials now reaches the world, ready to be held, used, and trusted.
And that's how smartphones are manufactured, from start to finish.